class example 3.61. Use an algebraic process to solve the following equation, and then verify both numerically and graphically. So first thing I want you to notice is that we have logarithms on the left side of the equation and just a number on the right side. So this is going to be one of our convert to exponential form types. So first thing we're going to do is use our logs of logarithms to combine the terms on the left side. We're going to take advantage of our first log law. So since we are adding these two logarithms, we can combine them by multiplying the arguments. And then the next step would be to distribute the inside of the log here. So just multiply this out and then collect like terms. And then now we are ready to convert to exponential form. So base 9 to the power of 1 is equal to the inside of the log. And then we would subtract 9 from both sides and set it equal to 0. And then factor. So I need numbers that multiply to negative 24 and add to negative 2. So our answers here are x is equal to negative 4 and x is equal to 6. But be careful, for this type of logarithmic equation, we need to look for extraneous solutions. So this is where we are going to verify to make sure that we actually have the proper solutions here. So first we'll try throwing negative 4, the solution, back into the original equation and setting it equal to 1. And if we simplify the inside here, you see that we have negative 9 and negative 1 for the inside of my logarithms. If we substitute 6 back in, then we end up with log base 9 of 1 plus log base 9 of 9 is equal to 1. And it turns out the one on the right, our x is equal to 6, works. That is equal to 1. So the left side of the equation is equal to the right side of the equation. However, when we substitute the negative 4 back in, we end up with this situation where we're taking the logarithm of negative numbers, which isn't allowed. So this is telling us something. This is telling us that the solution of negative 4 is extraneous. So now let's see if we can get the same picture, the same solution, by doing it graphically. So we'll set y1 equal to the left side of the equation, and y2 equal to the right side, which is just 1. And then you can see that we only have one intersection at x is equal to 6. One more thing to note here, that when we're checking for extraneous roots, we're not just throwing out the negative solution. So I know that this one was negative 4, so you might just think, okay, no negatives. We can't take the negative or the log of a negative number, right? But this may have been, we might have thrown this negative 4 into the original logarithm, and it might have turned out that we weren't actually taking the log of a negative number, right? So just, you actually have to put it back in to make sure that you are indeed taking the logarithm of a negative number.